Okay, this next guest is a personal favorite. Liran is my other personal guru. He's my colleague and friend at SNCC. He's a developer advocate and a member of the Node.js security working group. He's a JS Heroes ambassador, passionate about building communities and the open source movement, and generally enjoys pizza, which he should because there's a lot of it at meetups, wine, web technologies, and CLIs. Liran is also the author of Essential Node.js Security, a core contributor to OWASP, NodeGoat project, and loves to dabble about coding, testing, and software philosophy. But you don't know that he also wrote the serverless security book by O'Reilly with Guy Podjarny, and he loves his Yoda hat, and he wears it at every single conference talk. Liran,
That's true.
good to have you here. Excited to have you
Hey,
here.
Sharon. Yeah, that's a pretty good intro. I feel like I should have been born in Italy just because of my affliction for pizza.
Everybody loves a good pizza.
True.
Liran is here with us. He has a pre-recorded talk too, only because he wanted it to be so perfect and not miss a beat. So we're gonna let it roll and prepare your questions and comments for Liran, and he'll be here to answer them after his talk.
See you also. Hi, everyone. Thank you for joining my session on packages for mass consumption. Today, we're going to talk about some stories and security incidents on the NPM ecosystem, hopefully to learn some practices and tips that we can take with us as we work with open source packages and dependencies. So my name is Liran Tal. I'm from Israel. I'm happy to be here. I'm a developer advocate at SNCC, where we build and help developers around open source security. And so I love open source. I love building things. I love security. Some of my work has been around publishing my own book around node security, co-authoring a book about serverless security for O'Reilly, some things around OWASP, so some projects there. So any of those, you can, if you want to discuss about any of them, you can just ping me over at Twitter, Liran_Tal, and we can chat it up. So let's kick it off. Maybe you haven't noticed, but there has been a total mind shift in how we build projects today. Some 10 to 15 years ago, the first thing we did when starting a new project is to begin writing some code. And as the need arose to add some libraries, we would do it, just add it. And if we got to a point where we needed to do a drag and drop library, we'll search for an open source project and add it to our project. And so today, I think we have kind of like starting to use project generators in a way that has been kind of like the default thing. So a good chunk of open source libraries as a starting point is, just to go ahead and add libraries. So if we build a front-end project, a typical start for us would be, let's add React Router, let's add Redux, and so on. And so similarly, if you were building a backend project, what steps would you be doing, right? npm init, npm install express cookie parser, and so on and so on. So we are very much dependent on open source packages, just to start off a project, right? And as you begin to realize this, you can see the concern coming up. And so one of those things is the challenges, in managing open source dependencies at scales, right? And so NPM has over 1,300,000 dependencies. And so what exactly should we be doing and how should we be managing it? Should we use lockfiles? If so, how should they even work, right? Should we use lockfiles for just for projects or also for libraries, or what exactly should we be doing there? How do we keep our dependencies up to date, right? What's a good way to automate around this? What's a secure way to do it as well? And so we're going to talk about all of those projects and more through stories in the NPM ecosystem. And so everyone are pretty much aware, if you've done any JavaScript or Node.js project, you're aware of the package JSON manifest, have your scripts, you have some other kind of like key fields there. But also the fact, that there's some kind of dimensions around what a package and the version actually kind of comprise of. And so one of them is that every package has an explicit version attached to it. You can't change that version. You can't, republish the same version twice or more. It's just one atomic version once you've set it off. And there are some controls on the NPM ecosystem, the registry itself, to allow you, if you needed it in a safe way, to kind of like roll back, but again, without breaking the entire ecosystem. So how does this look like? We have this list of dependencies. We see here an example where we have Fastify that may take in something like debug or something else, and we have a way to also call another debug version from a different dependency. So it's very much possible for a couple of dependencies to actually require two different versions of one package. And this is one of those first things that we just begin with understanding how our dependencies managed underlying by the package manager. So we talked about the fact that we have many versions possibly for a specific package if that's what is needed, but understanding this very acute aspect may have several consequences on your app. One of them is, for example, when you need to bundle assets for a front-end app, when the size actually matters, you probably don't want to duplicate the same package if you could, right? If the two versions are actually pretty close and there's no really reason to do that. And so there are some plugins, like this one that helps you understand what is going on in terms of your packages and the versions that you include. And that's kind of like, starting off or chaining the story of understanding what are we actually bundling and what are we actually requiring to build all of this. And so there are other kind of like manifest kind of metadata like licensing, immunity, and some other kind of things. But what this actually leads us to, I think, is one of the greatest virtues of NPM, and what it had actually popularized, and this is the semantic versioning, that was coined, just because this is purely semantics, right? No one enforces it, but hopefully, if we all kind of like act as good citizens, we're actually building something, around specific kind of like guidelines. And so you have the major version. If there's any breaking change or you're releasing something completely new, you probably want to bump this one up. You have the minor version, which is usually reserved for features or anything that is actually backwards compatible with what else you're building and releasing in this version. And finally, right, that patch version for anything like a bug fix. But also for a security fix, right? This is the important key part here. We want to make sure that those security fixes actually, smoothly flow to our consumers very fast. And so we do not want to gate them on something like a major or a minor version that may require more due diligence into the upgrade process. And then there's the package manager can decide how exactly you want to update your dependencies, when you want to update them. So there's this way to tell it, I actually just want to update all of those minor versions up. And so I can also, if I actually use this tilde, I'll 147 is actually fine because this is actually like a patch version that is okay. 149 is also okay. But this minor version, if I need to jump from 4 to 5, that's not okay. I do not want to do this automatically, and this is how I tell the package manager to do that. Obviously, I'm not going to jump to 2 as well because that's a major version entirely. And then you can be a lot more permissive in the way that you want to update your dependencies. So you want to get all those patch versions as well as those minor versions. And so if you provide a carrot when you do semantic versioning, that always works for you, except it doesn't let you, completely forces you to get updates on major versions because those, probably shouldn't do them automatically. There are ways to kind of like circumvent this with like wildcards, but we're not going to dive into this yet. So these tags are a different way to kind of relate releases on the NPM ecosystem and associate like specific tags to them, just like we have version tags. This is actually what it is. It's version release tags. And so when you have, we said a package and a version are kind of like a unique tuple. And then when you do an npm install package, what actually are you getting? So you're getting the latest version, but how does that work? That's because when you publish the package, npm actually understands this latest version in it. And it actually does this mapping for you, unless, you could create your own tags or decide on publishing with a specific tag as well. And so there are different ways to see it. If you just run, npm show yargs, for example, if that's a package. If you do npm view yargs, it will show you some extra metadata about the package, including its these tags, which helps you understand, what is going on with that package, as well as a bit of insight into how the package is actually managed as a release process, which is also interesting from a maintenance of the project point of view. So, the next up is all about CLIs, right? Some of the packages that we'll install are actually, executable, programs that we can just run, like, for example, npm itself, npx, and so on. And we have a way to kind of say, what exactly do we need as a metadata of like, if this project or npm dependency is installable, I want to force a specific lower boundary of, for example, the npm client as a manager or the node itself, and I can of course do some other things around it. But this is kind of like now bringing us into the world of lockfiles, right? Like, if we want to make sure that we are actually installing something in a way that is a deterministic installation process. So if we run install once and once, again, and if we repeat that across, different developers on the team or contributors on an open source project, we want to give it very deterministic flow where all the packages and their versions are actually the same and not different and not pulled in a different way. And this is where lockfile kind of got introduced in a way of helping us understand how to do this in a way that is consistable and maintainable. And so this actually introduced, lockfiles are actually introduced in two different ways, right? Or different other package managers like pnpm, but we'll kind of like talk just about npm itself and yarn as the popular options out there today. And so, they all, they both generate their own lockfile, which may look something like that. And this brings us to an interesting incident that could happen, out of using lockfiles, a security one that is, probably not something that you would think of, but could generally really happen. So this is a real example, of me just opening a pull request for a project. You can see that I've updated some of the dependencies in this project. You can take a look, and I've also updated the lock file, right? And that's something you'd probably want to do, you'd need to do. So it's a machine generated, the lock file stuff is a machine generated. You probably don't really read all of those inputs into the pull request kind of data. And so what I did is, just updated some version. You usually need to do that, just to keep up to date. Except in my change, I'll go back a second. If you've seen, what's going on here is the diff is actually, it's minimized. You can't really see the entire log file here, and not really expected in a sense to view it, because it's, like we said, machine generated. You're not going to track each, checksum and so on to figure out, if that's the correct one or not. But maybe you should, right? Maybe you should actually do that in a way. Because what I've done with this pull request to a project is actually, if you look on this in the lower part of the screen, that bigger diff is actually me changing the source of the MS, very popular package downloaded by millions of times a week, from being on the npm registry to basically getting that from my own GitHub repository of MS, which I keep, which npm has no problem, or Yarn no problem pulling the source from. And so what you're getting is actually my version of it, which you may not know about it, and I may have changed it and done some really malicious things there. So if you actually don't kind of like do due diligence on your log file, that's a problem, because someone can again go ahead and make those changes for you as well. So one way to mitigate that is using log file linters. For example, log file lint, which allows you to set some trust policies around your project, and says, I make sure everything is over HTTPS, because that's a secure medium, and I only want to allow sources from say npm in the Yarn package mirror, nothing else, nothing on GitHub, nothing in a different way. So that's one way of doing that, and then you ending up with package lock and the Yarn log files. But then there's some other thing that is also interesting, and that is the maintainer might use a log file to generate their project and manage the dependencies in a consistent way for the developers. And let's say that's the package log file. But when you build the package, when you actually ship it out to consumers, they don't get the package log file. So all of those dependencies that they get are actually dependent or resolved from the real-time install process based on the dependencies metadata on the package JSON file. So that package log file is actually only for those using the project itself. It doesn't really propagate and populate all over to the npm, as a registry or as an ecosystem for consumers. There are ways, to do that if you wanted to force it. They're called shrink files and so on, but out of the scope of this talk, just to let you understand, how log files, very vaguely, in a high level kind of work. So if you wanted to, if a contributor comes in and they actually wanted to get something, or contribute, they actually do have this way of saying, I will, when I install something, I am going to get all of those dependencies, and their deterministic versions based on the log file. but a consumer doesn't get it, right? A consumer, if there's, for example, Chuck as a dependency, you actually get resolved from this package JSON of Chuck and not the log file that Chuck may have in place. So this is kind of like how it works. And if we wanted to do that and force it, we could use this npm shrink log file. So this is a bit about direct and and indirect. And so the other thing is, we actually install only prod dependencies or dependencies. So when we install something, we don't get all of those dependencies. And that's another way of understanding that there are different ways in how package management actually, work and happens behind the scenes. So interestingly, how deep does this rabbit hole goes in terms of package management and so on. And so let me ask you a question, right? That is, what happens when a dependency break? Does it ever happen that the dependency actually break? Like, what something happened to it, and what happens if it does? So let's take an example. Let's say there's this Fastify project which depends on another project. So this is Fastify, and this is its dependencies, and I can say that it's actually dependent on AJV in a specific version. AJV also is dependent on something else. So you can see in the package, the dependencies of that package JSON, that's URI.js. If I look at URI.js, I see that it is being dependent on Punycode. What happens if and when Punycode fails for some reason? That's version range that will be resolved in real time for new installs for developers and in CI systems on builds. What would happen if it breaks? So to answer that, let's first ask, why would a package break? What are the reasons for a package to break? And all of which kind of like accounts to real significant disruptions for you to build or deploy your application, because you are now dependent on these open source projects. So one of them is, of course, breaking changes in the API. Another one is packages that may have been compromised in a malicious way. Maybe NPM is simply unavailable from a network perspective, or maybe you have network disruptions, in a way that help it. What about, maybe the maintainer pulled down the package from the registry because I don't know, he doesn't want to, or she doesn't want to, manage that project anymore. And so, realistically, is that even possible? Like, would a maintainer pull down a package? I don't know. Let's look at this as kind of like, in a threat modeling kind of way. This is, one of the things that could actually happen. So keep in mind, right? This is why we're having this talk. This is open source kind of world, right? Everyone can do in a sense as they please. And we have this, kind of like, code of honor or code of conduct, to probably not harm each other in a way, such as pulling down a package that, millions of other packages depend on. And if it did happen, what's the worst that could happen? So let's take a look from a real world story, right? So there's this developer who unpublished nearly 300 packages. Notably was one called LeftPad, which was used, by top projects like Node and Bubble. The NPM team, unpublished LeftPad because that caused like a major kind of build and CI systems to fail, and everyone was kind of dependent on this LeftPad project. And so, an interesting issue that happened here from a security perspective is that when that namespace was available, it was basically available for anyone else to register any other package called devpad as well, and all of those builds which didn't change any of their dependency mapping would actually get this new malicious package. How did it actually happen? Or why did it actually happen? Like, why would you unpublish a package? So without for judging anyone, but there was some legal issues going in with this developer. Not to say that anything was done bad on his or her behalf, but that happened, legal issues, and then NPM stuff changed their ownership of the package to this other entity, which wasn't the original developer. So as an act of protest, this is what happened, right? That developer had actually decided to remove all of their packages from NPM, all 300 of them. One of them happened to be that one thing that was called LeftPad. So let's take a quick look at LeftPad. This is basically a 17 lines of code of padding a string from the left, right? But which projects depend on 17 lines of code projects? or dependencies. Well, Webpack, Babel, JSCS, so many other projects. This has been a really, really bad incident that happened. The NPM, and as a community, we learned how to cope with it and understand what to do with it. But kind of like as a reminder, remember that at that point, LeftPad was in a state where it was unpublished, right? So it was unpublished for 10 minutes. And then someone else was basically able to push in a new version of LeftPad to kind of like fix the problem. Except if you think about it, what if that person called Cameron Westland was actually a malicious user, triggering something, a LeftPad clone that actually had some backdoors or Trojans or some bad stuff inside it. So there were some other issues, NPM needed to kind of like handle the situation and so on. And so this is like one story to let you understand, what, could go wrong and how you should probably protect yourself in different means and ways around things that could go bad like that. And, another kind of aspect is around dependency management, is understanding what we're bringing into the table. And so, I'm doing a lot of security research, kind of like reading, and one of them, one of those interesting articles has been a lot about, what is in the average dependency tree depth size when you install the average npm version. You can see this research specifically, compared NPM and PyPI. But interestingly enough, when you install an npm package, on average, you'd actually pull down more than 4 levels deep of an npm package, and that's you probably don't go to all of those node modules to understand what's going on inside of them, but it's an important aspect of understanding what we're bringing in. So we also named another kind of incident that could go wrong, when we depend on a package. That is, what if a package has been compromised, and did it ever happen? Didn't happen with LeftPad, even though it was similar kind of an incident. But actually, what happened in reality, this is again a real story. A security engineer has been able to compromise 14% of all of npm modules, which actually account to 20% of all those total monthly downloads. So these are actually very important modules on npm, and not just those that may not have downloads. And this may come in as kind of like a shocking way, but the security researcher who is working with the node, the node project and the node security working group, luckily for us, did not have any malicious attempt, but this was part of the ways to like test the security of the ecosystem. And when they actually obtained publish access, it wasn't one or two small projects that you haven't heard of. It's actually those projects like React and Express and so many others that they had actually gained access. But how could someone gain access to a project so big and so popular? Well, apparently people don't use passwords in a smart way. So a lot of people had their people here are developers like me and you, maintaining projects and packages on npm, had their passwords set to like really bad values, or like reusing old kind of like leaked passwords, which people are able to get online as well. So kind of a conclusion here: definitely enable 2FA, use a very good password and account hygiene, so that you not get an account takeover. And so bringing us into this enterprise readiness of how you manage your dependencies. So why do you need a local npm, right? We said there are some issues with npm, for example, maybe not npm itself, but generally speaking, with the ecosystem that may happen. And so one of the things that you could think of from an enterprise level, a lot of it is what happens if you have network issues, or just want to make install fast without going over a network request and so on. So would even the the npm registry would fail? So here's like, it's from a couple of years ago, but here's a status page, right? And npm does have its outages happening from time to time. But also, generally speaking, like we've said before, there's other reasons that you actually want to optimize for, more of like a local install of packages that is available around, for a team, for a group, for an R&D team, and so on. More than a local cache that you have with like npm and yarn on your own file system. So, another reason is, we're doing a lot of npm install, throughout the process, right? Webpack itself, if you install, this version, gets you a total of, over 1,000, total dependencies. That's a lot. You don't want to make network requests all the time around the team and your build systems for this. And so we talked about some other reasons, right? Packages could get yanked, and maybe private hosting in some services costs money. So one of the ways to do it is using Readiness. That's an npm project, an open source project you could use as a local npm proxy registry. But also, how do you actually, if you want to use Readiness, that's a really good way to kind of like go through this process of mitigating the risk of npm or something else happening in the middle of things, and breaking down your builds and your development processes from a dependency availability point of view. But then automating dependency management at scale, that's actually something that is pretty hard. Imagine you have a lot of microservices needing different things, and so how do you stay up to date with the versions that you need? Do you even know what versions you actually need to update to, and so on? That's a pretty hard thing. And so here, in this example, I'm using Snyk, for both of my security fixes and automatic pull requests, as well for like upgrading dependencies. And this is a way, in this case, it's Pinot or Pinot. It's a small and fast JavaScript logger that we can use, and we actually use this automated tooling, and we can use different other versions and tooling if we needed to basically keep our dependencies up to date all the time. But it's important to note, some of the things that you actually need in the tooling. For example, giving you release notes, giving you commit messages, giving you a bit of like dependency health to understand, what is the recommended version to use, when was it last released, so you can see your lag behind those latest version and so on. But a lot of all of those automatic updates could really mean a lot of noise on the project. So you would be getting, just hammered down with so many pull requests, and change requests to just update dependencies, and it could look very, very daunting. And so one of the key things you probably need is a way to actually say, I only want to upgrade, specific ranges that makes sense for me. Or another thing that you could say is, make sure that I only have, from this tooling, only say, 5 open PRs simultaneously. So, I do not spam, the developers to, kind of like communicate with bots all the time. Or you could always say, if there's a package that, you're using some, inside dependency that always gets, gets newer version, in a very frequent manner, you could say, I want to ignore that, any dependency upgrades to this package, or say maybe this is kind of like a testing framework or something that you do not really, care to be on the latest version on, and you actually want to do that as a manual process, you could do that. So, I think you need this kind of like tooling that helps you, make those smart decisions and be in a workflow that actually works best with, with your team. And so speaking about teams, right, I want to give you some takeaways, as we kind of like end the talk, and some kind of like patterns and guidelines of what problems and use cases, and how to fix them, how to go around them. So let's go quickly through them. So first of all, let's say my problem is my CI builds are slow, aren't deterministic with my development and so on. So what it means is when you run an install on CI, it may have different, even if it has a log file, it may have different results in dependency that it actually pulls. The way to do that is to run it with npm CI, or with frozen log file tag, and that actually gives you or gives the npm package manager of your choice a way to say, I actually want to force the log file, and if I need to resolve dependencies and they actually change between the log file in the project and the package resolution at that point, then I kind of like fail that install process. So you get something that is very speedy because of the resolution process, and it's kind of like surprise free builds, right? Because what's going to happen there. Another problem is, for example, maybe my developers often can't reproduce, that bug in production, in their environments. So it's a very small tip, if you haven't been using NVM until, this date, the node version manager, if different people work on the project and they end up having different nodes running, node versions, that can be problematic because, they may not be able to reproduce those versions. So NVM allows you, not to just manage the versions on your, on your local install of, just moving between one to the other, but it also allows you to just place a config file and, in a project. And when that user, what the developer has has NVM installed, NVM will actually switch to that version that is specified in the manifest. So it's actually a very cool way and easy way to make sure everyone kind of like aligned on the same version of this extra tooling. One of the other problems may be, I'm concerned I'm installing Node.js, modules will actually run malicious code. And so one way is npm as a package manager has this ignore scripts flag, command line flag. And so you could set that as, configuration option, or probably you want to start off with a command line flag. And when you do that, what it actually says to npm is do not run any of those post and pre-install hooks, which may end up basically running, commands arbitrarily that were specified by that package, which as we said before, could be, of malicious origins. But yeah, it may cause a bit of grief with, other npm run scripts. So don't set that, as a config setting to begin with, like I said, and, see how that works. What if I'm using packages with known security vulnerabilities? So, a really good way start off, as a default thing, you have npm audit kind of like telling you, or maybe you're using Auto's dependency check as kind of like telling you, these are your dependency and vulnerabilities. Sneak test, of course, is something that you could also use. Happy to explore and chat with you more about all of the upsides of that if you want to chat afterwards. And basically the idea is you understand which dependencies you actually use, get the dependency health, and get all of those like security of third-party dependencies pulled into the project and monitor it continuously, and so on. But happy to chat more about this afterwards. So one maybe before last will someone compromise my npm account and publish malicious code? So go ahead, enable 2FA, that's super important, and then make sure that every time you deploy something, an npm package, you actually have a 2FA code to log in or publish a package. And maybe that coming into like the close of the slides, one of those last items is if you're afraid you're accidentally leaking secrets into a config file when you publish a package or when you work on an open source project, you could do two things. So one of them, there's this filed metadata in package.json, which you could use to just specify and have an allow list of files that will actually be published. So you have to like manually add something there. So there's no risk of you mistakenly adding generally some stuff to your package, or use detect secrets, which is a module that wraps around kind of like Git hooks to make sure that when you commit or when you push, there's nothing that's secret files that are pushed into the repository itself. So it's like more of a code versioning issue. So like we said, we're going to wrap it up. Thank you for staying with me. If you want to learn more about, open source security, Node.js, building command line tools, testing, whatever, I love all of these subjects. Reach me out on Twitter at Liran_Tal. Thank you for being here for this talk, and I hope I catch you on later on the conf. So thank you.
What an excellent talk.
Thank
and
you.
I'm not biased because I'm from SNCC and because I think that security management of dependencies is important. It is one of those things that sometimes creeps up on you and surprises you. There was one question in the chat that you kind of answered, but if you want to repeat it here for those who maybe aren't following the chat, what do you think of Dino's dependency management, and what's your take on that?
Yeah, sure. So I think, generally speaking, Dino is a pretty wild experiment in a good way, right? We're exploring different things, different paradigms of how to build, different node apps in like different architectures. So it's going to be an important and interesting way to see how it evolves to the ecosystem. But generally speaking about the package management, and this is all personal opinion, I do think, eventually it will grow into needing kind of like a package manager. It's just there's so much that a package manager helps you, and that is npm in a sense has kind of like revolutionized the way that package management is done for language-based ecosystems on JavaScript, which other ecosystems are kind of trying to keep up. And you see the problems in different ecosystems where there are like multiple package managers and they're just moving from one standard to the other, and it's so hard to keep up. So I think there's that, and generally speaking, there are some. I think there's still an issue open on the Deno repo probably around some like security concerns and how packages are managed. And so with Deno, you have to like specifically execute and type in the module you want to import, and like from a URL, right? You don't actually install anything. Like there's no node modules for or something like that to manage that. And so when you do that, what happens? What happens when you're maybe requiring something from like an insecure resource, like an HTTP, insecure transport, right, and HTTPS and so on. So I think that's like one example, but it's not a complete one. That's basically what I got on it. Happy to explore and get more of these kind of things if you want to like shed more light from different perspectives on that. So definitely reach out and let's chat.
Cool. Okay, so you talked at the end a little bit about use cases and things that you can do. But for folks who are looking to get started and aren't so familiar with kind of the dependency management kind of landscape, what would be kind of your first steps in telling them how to integrate like better security, better dependency management?
Right. So without a doubt, we understand that managing dependencies is a very complex task. When you have hundreds of microservices and projects that depend in your repository, that's or under your team is even more complicated. So I think one of the thing is to realize is what are you actually running, right? What are the versions? Are you out of date? There's an interesting library called libyears, and what it does is it tells you the drift between a package version of all of your packages in years, right? In the years of when they were last updated. If you run it, if you try just experimenting with it, you might end up seeing that for a lot of packages, all of those indirect dependencies that you have as well, you're probably years away from the latest version that you should be probably upgrading to. And the problem with that, I guess, being out of date is the fact that when you're out of date, it doesn't essentially mean a bad thing. But when there's a new security fix and now you need to upgrade, and jump few versions up, major or minor, that might be a bit more risky. So it is actually introducing kind of like an inherent lag into your process of how fast you can actually upgrade without losing too much risk and sleep on just doing the jump. So I think an easy way to get going, obviously, if you're using npm audit is by default there. It's going to help you. Obviously you need something a bit more. I would say, I don't want to say production ready. npm is just production ready, but there's so many things that you could do that's more than that. Like if you're just using npm audit, that's a great starting point. But if you're not testing your project periodically, there could be a dependency that has a new CVE assigned to it, a new vulnerability. You may have not run a build for like the last 2 or 3 weeks. How do you know that nothing else is now is impacted by this new vulnerability? So you either need to run very like cron jobs of all your builds and all your dependencies, and every time watch if there's something new in the build, or you could monitor that. And there are good ways of doing that. And whether you choose to go with Sneak or anything else, there's good amounts of projects to do this as well. So these are all the things that you should probably be starting off in adopting those kind of like enterprise patterns in your projects.
Yeah, so I think that Gil's shake-o-meter is relevant here too, right? So like, not only in the context of tests, but also in the context of dependency drift and things like that. You don't want to jump too far behind versions that when you upgrade, you don't include too much risk into your next deployment. What are some other thoughts on security in the context, not only of, so this was very NPM specific, but if we're talking about in the global kind of JavaScript ecosystem, what are some people not using NPM, for example? What are good best practices there?
So I'm going to refer this to give you more reading. If you just probably Google something like 10 NPM security best practices, you'll find those 10. I've built those, curated that list together with Juan from the Verdaccio project. It's a really good list to get started and make sure it's like a cheat sheet to make sure that you're on top of it. It has everything from dimensions of scanning for security, making sure that you have 2FA enabled. Definitely some of the things that we've gone through here. Other kind of like practices is, of course, if you're if you don't want leaking anything into the project itself, just using things like detect secrets from Yelp or and Git leaks from AWS or something else, just making sure that you have these kind of processes tied into your CI or your development environment via Git hooks or something like that, making sure that you just don't push anything else. Even if you don't want the package itself to just go out, if this is a private package and you don't want someone accidentally running npm publish and putting it out to the world, package JSON has this private true flag which you can add. So it's really just a lot of practices. There's definitely a good sum of that in this talk that you can take away, and that's what I wanted to basically give everyone here. But also, I'd say Google that 10 npm security practices. There's a lot there as well.
That's awesome. Thank you so much, Liran. This was fantastic, and not because I'm biased, because it really was. It was awesome being here.